And thank you to all of you in the IEEE BTS for this invitation. This is a great pleasure to be here. This conference was actually one of my first conferences that I attended here in Washington when I was still an engineering student at GW right across the river. And if you told me 35 years later I'd be standing in front of you giving a speech, I would have thought you were insane. Thank you for having me, and I hope that what I'm going to talk about today is going to be worthwhile. One of the things that I want to hopefully do today is plant a few seeds. All of you here in this room and all of us who are dealing with audiovisual technology are dealing with not only the past but also the future. IP-based distribution, file-based workflows, a data-centric future. And the fact is, the content that we hold at the Library of Congress, which is one of the world's largest audiovisual collections in the world and is the world's largest collection of everything in the world, for the items to survive over time, many of them are going to have to be digitized, especially audiovisual content, because as I'm sure many of you are aware, audiovisual carriers are ephemeral and they don't last very long. In fact, one of the things that one of the folks introducing me mentioned was a Rio, and one of the things we've realized is that one of the most ephemeral ways of storage are solid state chips. They actually don't last terribly long for an abundance of different reasons. And so hopefully I will not only give you a briefing on what we do at the Library of Congress, but perhaps gives you some ideas about how folks like you might be able to deal with some of your challenges or where you fit in this chain, because all of us are part of this chain. And obviously this is a very simplified chain from content production all the way through. And the one thing I left off of here was the final archive, because in the end, the stuff doesn't just go to folks' homes. There should be a little arrow off of here that goes to the content archive. And that's part of why I'm here today, is to get folks thinking about what that content archive needs to look like, because in the past we've had tape libraries or content libraries, and they've been physical media sitting on shelves. Well, to a great extent, that's going to change, or at least its form is going to change, and we need to start thinking about how our various roles in the content chain are going to affect what those future content libraries are going to look like. And so the future is now. IP transmission, both wired and wireless, file-based workflows are much more common and are replacing physical workflows like videotape and audio tape and things like that. However, over a century's worth of recorded content still exists, and if we're going to make our predecessors worth their effort, we're going to have to preserve that content, which is, radio and audio recordings, video and film recordings, and also beyond that, all of the virtual content, all of the gaming content, the software, all of that. And that's what we do at the National Audiovisual Conservation Center. And so hopefully, at least I'll give you some ideas about how to handle that tape library of the future, whatever that content archive is going to look like. So let's start off with what the Library of Congress is. Where do we sit in this entire workflow? Well, we're the world's largest archive. We're also, by default, because of the size of our collection, we're the world's largest research institution. We serve two constitutionally mandated functions. The language for two of our functions is actually in the United States Constitution. One is we are the research library for the legislative branch of the United States government. We are the Library of Congress. And so that civics lesson you learned in 8th grade about the separation of powers and the 3 divisions of the United States government, we live that division every single day. And one of the things that we have to be careful of is we have a very specific way of talking to other divisions of the United States government. If I want to talk to an executive branch agency, I have to go through certain rules for how to talk to folks, because I'm the legislative. I'm part of the legislative branch of the United States government, and the relationship needs to be maintained. The second function, constitutionally mandated function, is one of the two intellectual property rights that are enshrined in the Constitution. Ours is we are the legal copyright registrar for the United States of America through the U.S. Copyright Office. The U.S. Copyright Office lives with us. I'll make this a little interactive. What is the second intellectual property right enshrined in the United States Constitution? Patents. Very good. Thank you, Meryl, for speaking up quickly. Our total collection as of the end of 2016 is over 165 million items, which includes just about every type of content that mankind has ever produced. We have over 38 million books, over 5 million maps, and in the case of my division, we have over 7 million audio, video, film, software, electronic gaming, and learning items, all of which can be copyrighted under the Copyright Act. And our collection is roughly 80% copyright submissions and 20% acquired collections. My division is known as the Motion Picture Broadcasting and Recorded Sound Division, and we are one of 5 depository divisions, or what is known as depository divisions of the library. We are the legal maintainers of the copyright for our specific content areas, which in our case is all the audiovisual content. And my division is in charge of over 1.8 million moving image recordings, which includes both video and motion picture film. 3.6 million audio recordings of just about every single format you could ever think of, and over 255 million feet of film, and as Meryl mentioned, 140 million feet of that is nitrate film. And for those of you who may not know, nitrate film is famous for being exceedingly flammable and highly explosive under the right conditions. And our 140 million feet of 35 millimeter film, we actually calculated this once, one 800-foot reel of 35 millimeter nitrate film has the explosive equivalent of a quarter stick of dynamite. So if you do the math, we have about 80,000 tons worth of explosives sitting in our mountain in central Virginia. That's about the size of a small thermonuclear warhead if it were to ever go off all at once. It won't, because we keep it chilled to 25 degrees, and so hopefully we will never, knock wood, ever have any kind of fire. But that's part of our job, is to make sure that the motion picture film pre-1951, which is nitrate, which is most of the output of Hollywood that still exists, make sure that that survives into the foreseeable future. We also have the paper records regarding all of that collected content, the records of Hollywood studios, the records of collections, the paper records that were copyright records, and so on. And increasingly, we're receiving born digital content. We're not a static collection. We receive between 100,000 and 150,000 new items every single year. Out of the 500,000 items that are registered with the Copyright Office, we get about a fifth of that content every single year. And so not only do we have to maintain the collection as it stands, but we also have to make sure that we receive the things that are being sent to us and that we can preserve them and that they are documented correctly. This is the Packard Campus. If you ever come down to Culpeper, Virginia, and you look to your left as you're heading south on US 29, this is what you will see in the side of the mountain. This is the, about a third of the building is above ground, and the rest of it is in an old nuclear bunker in the side of the mountain. One side is the main collections building, which is a former Federal Reserve Bank of Richmond nuclear bunker. And the other side underneath the mountain is where all of the specially built vaults for the nitrate film collection are stored. And one of the nice things about working at the Packard campus is it's kind of easy on the eyes. So I thought I would share with you a couple of shots of what it's like to go to work every day in our mountain in central Virginia. The Packard campus was opened in July of 2007, and it was a gift from, and this is why it's called the Packard campus, from David Packard, which he was the son, or is the son of one of the Packards, or the Packard that made up Hewlett-Packard. And Mr. Packard, luckily, has taken an interest in film preservation over the years and has donated quite a bit of money, not only to film preservation, but audiovisual content preservation in general. And if you ever go out to Los Angeles, he's also built a second building called the Phi Stoa, Phi standing for the Packard Humanities Institute, which is in Santa Clarita, which is about 45 minutes north of Los Angeles on the 5. So if you ever go up to Santa Clarita, you look to your east, you will see this big Greek-looking white building, and that's the Phi Stoa, and that's the home of both the UCLA Film and Television Archive and Mr. Packard's collection alone. And so Mr. Packard really gave us the building that we have today. If it wasn't for Mr. Packard's donation to the tune of about $160 million, we would not have the building that we have today. One of the positives of the Packard Campus, and one of the reasons that the library was interested in creating such a structure as the Packard Campus, is this is the first time the whole physical collection, all the audiovisual content, is in one location. Previously, it had been spread across 8 warehouses, both federal and private, in 4 states. And what this means is we've finally been able to start inventorying, cataloging, and most importantly, migrating, as in digitizing the content, and making it available. Because why are we spending tax dollars every single year on preserving the content if it's going to rot away into nothingness and nobody can use it? We are the world's largest research institution. Folks should be able to access our content. And so that was the mission of building this building on its own, or to have this standalone building, was to digitize the entire collection that wasn't already digital, and virtually none of it was digital before the building was opened, and bring that content that we have into the light. And we have some of the world's unique content, some of the only copies of some of the material that still exists. So if you've ever seen, for example, The Great Train Robbery, the early silent film where the cowboy ends up shooting at you, shooting you in the face from the screen, the only original copy of that is a paper print that is located in our vaults, and it was a gentleman by the name of Snyders in 1946 who took out that 35 millimeter strip of paper and photographed it onto 35 millimeter film, and that's why we all grew up seeing that motion picture film. That's the only copy, the only original copy of The Great Train Robbery. And you might ask yourself, 35 millimeter paper? Why did they do 35 millimeter paper? Well, before 1916, the Copyright Act basically said you could only copyright things that were printed on paper. And so guess what? Some cheeky monkeys at Edison's studio said, well, if we can only copyright things that are printed on paper, how about if we take a 35 millimeter strip of photographic paper and print our 35 millimeter film onto it and register that for copyright? And we have 3,000 or 3,300 paper prints that were done that way before the law was changed in 1916. And so we have to deal with things like that, unusual formats that were done for unusual reasons. For the digitization of the collection, we try and digitize in-house whenever possible. We use external vendors as needed, either because they have skill sets that we don't have, equipment that we don't have, and also if we're doing large migrations, things like the American Archive of Public Broadcasting, it's overflow for either time-critical items or for large collections that we may not be able to handle ourselves. And yes, there are collections large enough that if we want to get it done in a reasonable period of time, we're going to need to use more than just our skill set. Meryl was right. We do have one of the largest collections of antique equipment that actually works. 2-inch quad machines, open reel audio machines, Edison cylinder players, you name it, we've got it. But the fact is, there's only so many of these things that we can keep working. And so we have to work with private industry and with other institutions to migrate material whenever possible, because we're in a time race with how quickly all of this content and the media that it's based on are going to decay to unusability. And from our perspective, it's probably not a question of whether things are not going to be able to be recovered, it's a question of how much. And when we started inspecting our collection, we realized just what kind of a time limitation we had. We began digitization production in 2009. For digital content that is received through copyright submission today, we have to maintain that content. We have to maintain accessibility, searchability, and usability under the Copyright Act for a period of at least 150 years. And so that gives us a very different perspective on long-term planning. And the reason for that is the copyright registration for audiovisual works right now is a 75-year base registration with a 75-year extension. As long as people or organizations remember to renew their copyright at the 75-year mark, and there have been some folks who have not remembered, and so that's why certain things that everybody knows in this room are now in the public domain. But as long as you do that, we still have to maintain it for a minimum of 150 years. And so from our perspective, if you look at it from an engineering perspective, from a planning perspective, it's essentially a permanent data set. And for the items that we received today, here in 2017, it means we have to keep them accessible and usable until at least the year 2167. That's the equivalent of someone sending something to the library in the year 1867, 2 years after the Civil War ended, and expecting us to have it accessible, searchable, and usable this year. That's what it's the equivalent of, because that was 150 years ago. So it's essentially a permanent data set, but it's also the cultural record of the United States and many other countries, because we have a strong copyright registration law here in the United States. Many people register here not only because they know they will get copyright protection, but also they know that we will be able to preserve their content. And so many of the content producers worldwide end up coming back to us in the succeeding decades after a work is created, because they want to restore it, because they've lost their copy, because somebody's had a fire, because somebody's lost something, because their sand died, because something happened. And lo and behold, the library in many cases has the only copy of the content that they have, or one of the only copies that still exists. And so that means we have many unique items, including some of the only copies still in existence, or sometimes the best copy in existence. And so when you see things like the restoration of Lawrence of Arabia, some of those film elements came from our vaults because we had the best quality film element for whatever portion of the film that they used our film elements for. So this means that we have a very different perspective in long-term planning and developing, requirements for the long term. However, it's not that different from other organizations. For those of you who work for content-producing organizations, obviously this is the Broadcast Technology Society, and so a big part of the job here is to get the content to the end user. But for the folks who also produce content, many of the organizations have the same challenge that we do, because their content is still monetizable. It's still usable over time, whether it be public content like public media, or it be commercial content. It's still usable over time. And so the ability to preserve that content and for folks to be able to see footage from the Vietnam War used in a Ken Burns documentary, if it weren't for film preservation, many of those elements would not still exist today. So how do we enable long-term survivability? Well, many folks have come up to me over the years and said, this is such a big idea, 150 years, 7 million items. How do you get your head around it? And the fact is, 11 years ago, we sat around a conference table with a bunch of 11 by 17 sheets of paper, and we started writing it out. Because when you get real about it, when you get zen with what the challenge is, that's pretty much what you have to do. You have to sit down and you have to figure it out. The difference is, in most cases, folks are doing something for the next 5 or 10 or 15 or 20 years. In our case, we're doing something for the next 150 years. And so not only do we have to take into account the engineering and the organizational challenges of today, we also have to do temporal engineering. We have to think about, how do things age over time? How is the media that we're going to store this, not only the media that we have to digitize, but the mediums onto which the data are going to be recorded? How are they going to survive over time? When do we need to migrate them? It's not a question of if, it's a question of when. And the question is, how do you know when? And how do you make sure that that data set is as perfect as it can be? And there's no such thing as absolute perfection in this world. But how do you make it as perfect as you can make it over time if your goal is 150 years in the future? So that means If you do a migration every 10 years, that means a minimum of 15 migrations in the next 150 years. If you do it every 3 to 7 years, do the math. It's that many more. And you have to wrap your head around it and say, okay, what do we do? And how do we get there from here? And so that's part of what I'm going to be talking about today. Also, if you're going to enable long-term survivability, one of the earliest things we realized, especially in the compressed digital audiovisual content era, is that preserving content as close to the original quality as technically feasible should be one of the goals. Now, there's a cost benefit there, because the higher the quality, the more data you have to deal with. But as we started realizing how much data we needed to deal with, it actually wasn't that much more than we thought. A 50 megabit per second MPEG-2 file was actually larger at SD than a losslessly compressed JPEG 2000 file of the same resolution, digitized the same way, but losslessly compressed. And so when you start doing the math, sometimes there are economies of scale, or there are economies that come out. And so one of the things that I always tell folks is, when you're looking at preserving content, don't assume going in that you can't do something that can maximize the quality of what you're saving over time. Because remember, if you use lossy compression, that lossy compression is going to be what people view for forever. That's it. Once you've thrown the original away, or once the original's gone and you can't recover it and do a better migration, once it's gone, your copy is probably the best quality they're going to see. And who knows how many different compression schemes, how many different technology changes are going to happen over the next at least century and a half. So this is one of those things where if you think it through, sometimes the assumptions people make about how to preserve things are not necessarily correct. So think outside your personal and professional boxes if you're going down this road. And so one of the things we realized was we wanted to preserve the content as close to the original quality as possible, and luckily the technology is there. We can produce the best quality that can be gotten. But also we realized that there were certain things that needed to be adjusted, because most of the standards that have been set, whether it be SMPTE or IEEE or AES or any of the other standards groups, AMWA, for audiovisual content, one of the things that we realized is they were production specific, as in original production, new content. And so the standards that were there, for the most part, will work for preservation with a little tweaking, but they have to have a little tweaking. In some cases, like the AXF effort that Meryl mentioned, there were things that needed to be done. We needed certain skill sets. We needed standards to be created to preserve things in ways that had not been thought about before. In the case of AXF, that's a standard for how do you preserve data over time. That's the purpose of it, or at least that was the original purpose of it. And one of the interesting offshoots of AXF is, as we got to the standard for preserving things over time, suddenly it looked like, well, this could actually be a good standard for how you transmit content from producer to producer, or from producer to network, or from network through various workflows into the content archive, or to registration at the Library of Congress. It's not just archiving. It's throughout the file-based workflow. And in the case of MXF, we realized that we needed to adjust MXF, because MXF was a very good standard and it did most of what we needed to do, but we needed to adjust it in some ways. And so the AS07 spec was the spec that not only the Library of Congress, but a group called the Federal Agencies Digitization Group, which has the acronym FAGI. One of the things that when we got together with the National Archives and Records Administration and NASA and other groups that had large collections of audiovisual content, is that they had many of the same challenges that we did. And so that's where the MXF AS07 spec came from, and that will actually supposedly be published sometime this fall. And it looks like at this point it'll be coming out from SMPTE, probably as an RDD. But if you want to see what the actual spec looks like and you want to read it, go to what is it? digitalpreservation.gov, I believe, and click on the FAGI, F-A-D-G-I link, and you will get to the MXF AS07 spec. One of the things we realized also is we couldn't invent a lot of black boxes, and in fact, we really didn't want to invent a lot of black boxes. And so we realized that using off-the-shelf technology whenever possible not only had benefits from a cost perspective, and when you're starting a 50 to 100 year digitization project, and that's what 7 million items means, it means 50 to 100 years of digitization. It means that folks like me who were here at the beginning are not going to live to see the end of this, which is as an engineer, that's a very strange concept. You know, I'm used to taking a project through to its logical conclusion and seeing the output, and I'm not going to live to see the end of this one. And that's a strange concept, but once you get your mind around it, again, you realize that this is a relay race, and it's part of our job to hand the best baton as possible off to the next folks. And so we innovated whenever necessary. We created, or had created for us, the SAMA system, the System for the Automated Migration of Media Assets, which was the first practical reversible 5.3 mathematically lossless JPEG 2000 encoder. And the follow-on encoders from places like OpenCube and Delette and some of the other folks who have gone on to produce JPEG 2000 reversible 5.3 encoders that can do high definition and 4K and hopefully in the not too distant future 8K. We decided on JPEG 2000 as the standard for us because it was a mathematically lossless way of compression that gave us an average of 2.5 to 1 compression ratio, which when you know that you're doing a 100-year migration and you know that you're creating an exabyte-sized archive, you know that a 2.5 to 1 compression ratio is real money. Probably billions by the time we get done, if you count everything that has to be done worldwide. And so 2.5 to 1 compression with no loss in quality has, and no footprint in the audio or video so that future compression schemes would take a quality hit, that has some really positive aspects to it. And then things like transcoding and rewrapping systems, which allow us to seamlessly interoperate with industry, because one of the realities is 3,000 to 6,000 times a year, we get approached by Hollywood, by the television networks, by content producers, large and small worldwide, and they want to either license content from the original producers, or they want copies of things that are out of copyright from our collection for use in whatever production they want to use it in. And so, unfortunately, a lot of folks don't do JPEG 2000 lossless in MXF, but they do 422 ProRes, they do DNX HD, they do all these different flavors of production files. And so one of the realities of our job is 3,000 to 6,000 times per year, we need to interoperate and hand somebody content that they can take to their editing system and be able to use it. And so transcoding and rewrapping is a part of our job as well. This is our archive and proxy file list. This is the short list. Basically for audio, we do broadcast wave. For content that's digitized for the first time, we do 9624, 96 kilohertz, 24-bit. And right now, our access proxies are uncompressed waves at 44.1 16-bit. Over time, we may switch to something like MP3 or whatever the future MP3 is going to be, if necessary. But at this point, the data rates on 44.116 audio are low enough, and we've built our system to do the biggest data rates that we can because we're doing film and video. No offense to the audio folks out there, but audio is a rounding error for us. It's not a big deal. So doing 44.116, except for server space, of course, which is a consideration, for the tens of thousands of audio files that we have, we're not breathing hard with doing stuff like that. For moving image content, all moving image content, both video and film, our archive file is a JPEG 2000 reversible 5.3, mathematically lossless, encoded visual content in an MXF OP1A wrapper. And when MXF AS07 is finalized, we will start conforming that OP1A to AS07. If you read the AS07 spec, you will also notice that there are things beyond OP1A. If you know MXF at all, there are 10 different profiles in MXF. And AS07 accommodates half a dozen of them for some very specific reasons. I will leave it to you to read that if you are so interested. Our proxies for video are MPEG-4 H.264 encoded at 1.5 megabits per second. And up until the last year or so, we have been producing the proxy files at the same time we've been producing the archive files. However, it looks like, since a lot of our content is long tail, really, really long tail, probably less than 5% of our collection since we started in 2009 has actually been accessed. Our video collection has actually been accessed by somebody. We're looking at, and this is where transcoding and rewrapping has a new meaning, we're looking at doing it on the fly. So that since there are now transcoders that can handle JPEG 2000 lossless up to 4K UHD resolution, we can now get transcoders to produce an H.264 on the fly when somebody requests it. We don't have to take that extra storage space and store the proxy. And so, adjusting our workflows to match the realities of, day-to-day production life is part of what we do. Why spend the money on storage if we don't need to spend the money on storage? And then for film, we still create and edit and do dust busting and color correction in DPX because that's the most common format that's out there right now with BWF, broadcast wave RIF64 audio. But we convert our DPXs to JPEG 2000 lossless, reversible 5.3 in an OP1A. And that's because we get the 2.5 to 1 compression ratio, and we can seamlessly, we've got transcoders that can go back and forth between uncompressed DPX and JPEG 2000 really, really easily. It's just a matter of time and capacity, designing the system to handle the capacity. Then archive or access proxies we create in some cases before we actually do the preservation. If somebody asks for something, and the archive preservation for film scanning actually takes longer because it takes between, the film scanners take or can only go at about 6 frames per second to 14 frames per second for 2K and 4K resolutions. And so in many cases, we will actually produce the access copy before we do the preservation copy. Again, when folks want something for access, since part of our job is providing things for researchers, we focus on servicing those needs. One of the other reasons we decided both on JPEG 2000 lossless for film, but also why we participated in the AXF effort, was the limitations of storage file systems. The Library of Congress, we get a big kick out of how many times per year somebody says in the public media somewhere, or in commercial media, the news media, they say some new technology is 10 Library of Congress's worth of storage. And we always get a big kick out of that, because when you do the math, usually they seem to think we only have 10 terabytes worth of storage in the entire Library of Congress. And we produce about 250 to 300 terabytes of content every single month. And so, when folks talk, when I see something, the BBC, for crying out loud, didn't even contact us 3 years ago, and they said, well, this new thing from so-and-so can store 300 Library of Congress's worth of data, which was basically 3 petabytes worth of data. And we're like, no, we've got 8.5 petabytes in my division alone. And this is not the rest of the library. And so one of the things we realized as we started, looking at the experiences of other parts of the library who do journals, who do magazines, who do books, who do maps, and when they started digitizing or receiving born digital content, the other parts of the library have large quantities of small-sized files, small data-sized files. We're the exact opposite. We are small numbers of very large files. And so when we started looking at their experience with hundreds of millions of files, one of the things we realized about enterprise storage systems is if you go north of roughly 100 million files in an enterprise storage system, you'll still be able to use that storage system, but the system will start to bog down on searchability and retrievability very quickly. And we actually had to bifurcate at the 100 million file mark, and we now have 5 bifurcations within the library because of the namespace and the when going north of 100 million items, there are limitations in how the systems operate. And so one of the things we realized was if we were going to do DPX for film, I actually created this spreadsheet where you put in the number of feet of film and the format and the output that you wanted, and it will tell you how much storage you want to use. And by the way, 255 million feet of film with all of the different gauges that we have, and we have every single gauge ever created, is going to be, depending on what our output is, but it's going to be at least 250 exabytes worth of data by the time it's done. That's just the film collection. And so when you take a look at things like that, you realize, well, 10 million feet of film, we've got 255 million. 10 million feet of film goes north of 100 million items in a collection. And so at that point, we realized that doing things like wrapping of film collections, or because DPX uses 1 file per frame, wrapping those collections in a wrapper, whether it be AXF or converting it to JPEG 2000 and OP1A, actually had some real benefits when it came to maintaining a collection that's accessible and searchable in a reasonable period of time. And so that's part of what the decision-making process is in designing something like this, is realizing the limitations of various systems. And so when we looked at our archive file choices, the first thing we asked was, can we attain perfection? And the answer is, well, yes, digital imaging can indeed produce absolutely accurate reproductions, but if and only if the minimum specs for accurate reproduction are used, which means no less than 10 bits per color channel. And if you want to know why 10 bits versus 8 bits, look at MPEG-2 on the air. That's all I got to say. But also, do we need to go beyond 10 bits for, especially since we have wide color gamut and high dynamic range and other things coming down the pike, what needs to go beyond that to do the minimum quality necessary to maintain things like that? And then, do we look at either, or our two choices are either uncompressed or mathematically lossless compression. If you're going to use compression, use mathematically lossless. And so the two choices at this point are, do you use uncompressed, which are very large data sizes, or do you use mathematically lossless? And at this point, there are 2 mathematically lossless standards out there. There's JPEG 2000 reversible 5.3 and FFV1. And because FFV1 was not available in 2007, we did JPEG 2000 reversible 5.3. And then we maintain all of the original content specs, the original frame rate, the native frame rate, the native color space, the native raster specs, and so on. Digital audio can produce absolutely accurate reproductions when you digitize analog at more than twice the Nyquist limit. And the reason for that isn't the Nyquist limit itself. It's that if you ever do any kind of processing in the future, whether that be processing is lossy compression or editing and manipulation of the audio itself, doing a mix with the future digital audio, you need a minimum of 96 kilohertz 24-bit sampling for the extra processing overhead for things to be processed into the future. And one of the things we realized is this also applies for audio for video and motion picture content. And one of our technical challenges today is that most video encoders, or most moving image content encoders, top out at 48 kilohertz and 24-bit. And we had a couple of vendors that could actually do 9624. You could do the setting, but it would cause the computer to crash. And so one of the things we're working on is getting our vendors to the point where we can do 96 kilohertz, 24-bit audio for video and for motion picture film audio as well, so that it harmonizes the collection. It also allows future processing of any of the digital audio. And in the case of audio that's got a lot more spectral content, or you might need to mix down at some point in the future, we might actually go beyond 96 kilohertz to 192 or 384 for the collections that it makes sense. And then we receive a tremendous amount of born digital content now, and we maintain it in its original sampling structure. And for audio, there are two basic ways of doing audio. One is PCM, of course, and the other is direct stream digital. And one of the things that we learned when we started doing conversions between PCM and DSD is that it does not leave a footprint in the audio. You cannot go seamlessly between PCM and DSD. And so one of the things that we're looking at doing is creating an archive file for content that has been originated in direct stream digital, things like SACDs and other DSD type of content into the future. And then there are the file wrappers. One of the things we realized is if something's going to survive for the long term, you need file wrappers that are going to survive for the long term. And one of the realities of the audiovisual industry is that standards change fairly quickly. How many of us are still producing, not counting ATSC 1.0, how many of us are still producing MPEG-2 originated content? 1, 2, maybe 2. Okay, and you know, the ATSC over the air, which is still MPEG-2 at this point, is going to go away within a few years, and suddenly we will have virtually no MPEG-2 type of content. And MPEG-2's only been around for what, 20, a little over 20 years now, and it's already sunsetting. And so one of the realities is if you're going to save content over time, not only do you want to make sure that you don't use a codec that's going to go out of service, and that means that if you're going to use a lossy codec, the code either needs to be maintained for that lossy codec or you need to look at doing something else. One of your other choices is how do you organize the data? How do you wrap the data? And so for long-term survival, we realized that having file wrappers based on well-documented international standards was the preference, and that's what MXF is. It's a well-documented international standard. That's what WAVE is. It's a well-documented international standard. Then one of the other things we realized was if you are going to produce all of this content, a key aspect to all content is metadata. Description of the content that you have, the technical metadata that is more than just the specs that are in the header, all the different things that go into it. And so we realized that including certain types of metadata actually in the files would be preferable over time, so that if external databases are lost, you still have copies of the data inside the file, and you could just read the file and rebuild those databases. Because if there's one thing that I think many of us who've dealt with data have learned is never assume your database is well enough backed up that all the changes are there when your database goes offline. How many of us have lost a database and had an error with it when you brought back the backup copy? Enough of you. You know the pain. Oh, the pain. And so one of the realities is if you're going to survive over time, probably that database that is external to your content is probably not going to survive over time, or it's not going to survive in the form that will be usable. And so having copies of the metadata inside the files becomes important. Part of our challenge was also to design the workflows for physical carriers and for electronic files. We needed to be able to have the humans actually be able to physically catalog our large collection. And one of the most awakening moments was we thought going into this project that 40 to 50% of our 7 million items were adequately cataloged, or at least basically cataloged. And as we started receiving the 5,000 tractor trailer loads of content at our building in Culpeper, Virginia, and we started taking things out and putting things on shelves and doing a shelf survey as we were taking things out of boxes and putting them on shelves. The color drained from our faces, because our collective faces, because we realized about 20% of our collection was adequately cataloged, which means that 80% of that 7 million items would need to be gone through and would need to be cataloged properly. And so that is not a small challenge. That's over 7 million items in total. We also needed to move large items or large numbers of items quickly. If we're going to digitize, we need to get things through the system as quickly as possible. And that's why when we had the SAMA encoders created for us, we also had a robotic system placed along with it so that we could do mass migrations, not just one-off with people shoving tapes into cassette recorders. And so for both audio and video, and soon for film, we have both hands-on migration for sensitive things that need, tender loving care, but we also have portions of the plant that are dedicated to mass migrations. They are robots that can do, 48 or 60 video cassettes at a time. They could potentially do 8 or 10,000 feet of film at a time. They could do, 8, 16, 24, 48 cassettes or audio tapes at a time. And that's how you get through a collection quickly. But the key part of that is you also need to be able to do a consistent digitization for every single piece of content that comes through. So we needed to move large quantities of items quickly. We also needed to have plans for how to handle fragile and degraded media carefully. One of the realities of our audio collection is we have a large number. Just the NBC collection alone is a good example. We have 135,000 transcription discs from NBC radio. And one of the problems during World War II is the way they made transcription discs was before World War II and into the beginning of World War II, they put a coating on an aluminum disc. Well, as the war went on, aluminum became quite valuable, and so they started using glass. Well, when you do a laminate, what is the one thing laminates tend to do over time? They tend to delaminate. And so here are all these recordings that are on glass, that are on metal, that are not solid pieces of vinyl, that we now have to figure out a way of recovering audio from broken, cracked, degraded surfaces. And so that's where some of our, black box projects like Irene, where we use cameras, video cameras and line arrays to read the grooves without ever touching the physical media. That's why we would develop, things specifically for degraded media. A key part of what we realized as well is because we were going to be producing large amounts of data, because that data was going to be into the exabyte range over time, even if I don't live to see the first exabyte. I hope I live to see the first exabyte. That would be really cool. We'll put a sign up, 1 exabyte. We realized that we needed to use enterprise class IT for both our production and our archive backbone. That means the data quality for all of the Ethernet, for all of the data connections, for how we're storing the data in our data library. And then what we also realized was we need to create provenance data for how we did things. And so not only do we document the processes for how we digitized, but we also create QC files for every single file we produce that says, okay, at this moment in time, at the moment that this file was created, this is what it looked like for future selves. So if there's a problem, or if somebody needs to figure out how we did something, there's a footprint for how the file was at the point of production. And we save those QC files along with the original content. The problem is QC systems today can't handle the type of QC that we need in the quantity that we need it. And so we're only getting probably 5 to 10% of our content QC'd at this point. So one of our major efforts over the next decade or so is going to be getting the QC packages that look like they are promising enough that they will have the skill sets that we need to tell the difference between a space shuttle launch and quad head banding. Right now, the QC software can't tell the difference between the plume on a space shuttle launch and quad head banding. How many of you know what quad head banding is? Thank you. Okay, good. At least you know what I'm talking about. And right now, we get files that are defined as bad or affected, and they could have flash bulbs going off in them or a plume from a space shuttle. And the QC software will give us the same error as quad head banding. So clearly we need to get that skill set to be a lot more intelligent and tell us a lot more about our content. And then there's long-term archival storage planning. We need to plan for the data to survive for at least 150 years, but realistically, because we are the cultural archive of the United States and for many other folks around the world, it probably means forever. In many cases, our content will be the only copies of the content that will exist. How do we make sure not only is it the best quality that we can give them, but that it actually gets to the year 2167 in a condition that they can actually use? That actually takes thought, and it takes some not small amounts of implementation. And so we need to keep the data safe and verified, this is the real challenge, until we hand it over to our successors. As I said, this is a relay race. This is a marathon. We pass the best baton on to the next team, and we make sure that our successors are properly trained. And we also pass on the proper documentation, how the collection was created, what migration equipment did we use, what was its design, what were its operating instructions. We're not only one of the best customers of eBay, we also have one of the largest collections of manuals that you could ever want in creation. If you need an Ampex manual, we probably have a copy of it. And if we don't, we know where to get it. And then the basic technologies that built that content. One of the challenges that we realized, and in fact, we're running into this today with with the folks who come from college and do internships with us, is that the folks who are coming out of, you name it, engineering school, library sciences school, media production schools, they really don't understand analog. They don't get it. You know, I'm 52 years old, and I'm one of the last people to have grown up in this industry. I started in this industry when I was 15 at my local public television station doing production. I'm one of the last people alive today who used analog in its native environment, who knows how analog was done, because I've worked on a transmitter, an STL, a quad machine, DMOD, you name it. I've worked on those things. I'm 52 and I'm one of the youngest, and that's scary, because the next generation, the people who are coming after me, the people that folks like me have to train to replace us, grew up in the digital era when everything is perfect, and the problem is it's not perfect. You know, it's just hidden until it goes bad. And that's one of the concepts. I teach classes on this a couple of times a year, and one of the things that makes the students' heads spin 360 degrees when I say this is all digital is analog, because it is. It's a payload in an analog carrier, waveform, whatever you want to call it. And we need to get folks, the next generation of folks, to understand what those challenges are and to take them seriously, because in the end, not only do we have to recover the stuff from the old analog carriers, but the fact is, if we have any problems with digital in the future, it will be probably because something's wrong in the analog storage system that it's using. Things like that. So our current status is we've been in production for audio since February of 2009. For video, we've been in production since October of 2009. With our physical film lab, we've been in production for several years now, for about 7 years now. And we are, for electronic scanning, we have been doing roughly 1 to 2 films per year, and this year we're ramping up to 4 to 5 and see, you know, if the number of people we have and the amount of equipment we have can handle 4 to 5 films a year. To date, and this is where file size and file number are completely turned around from the rest of the library, we've produced 180, or a little over 180,000 archive files to date. That's since 2009. But they make up 8.5 petabytes worth of content, unique petabytes worth of content. And so, you know, we have, compared to other types of files, very large files. Quality control is still mostly manual, as I mentioned, and we're working on getting that a lot more automated, but it's going to take years, and it's going to take money, and it's going to take hand-holding to get the vendors there. Our data archive is right now 2 copies geographically dispersed. To be archivally proper, you're supposed to have 3 unique copies geographically dispersed, and unfortunately we have not had the money to implement the 3rd copy yet, and hopefully nothing will go wrong. Our storage system is a data tape system, which is the Oracle Storage Tech T10000 series, and right now we're using the D format, which is 8.5 petabyte or terabytes per tape. We have a data robot, or 2 data robots at 2 different locations with 9,800 slots, of which 4,900 are currently populated. The way we maintain data security and data integrity is we use SHA-1 cryptographic hash checksums to verify the integrity of the files, both while they are in transit to the archive, but also we scan every single file in the archive. Well, now about every 2.5 years, we scan every single file. We regenerate the SHA-1, we make sure there's no data rot, and if there's data rot, we have one other copy that we can draw on to replace the bad data. One of the encouraging things is we've been in production since 2009, and we've had 3 major migrations and 3 runs through of the entire collection. And we've had several dozen data errors, but none of the data errors have been original problems going into the archive, and none of them have been data rot on the data tapes, which is very encouraging. It's a lot better than we thought it would be. And it's, luckily, that's kudos to our enterprise IT team and how they've maintained their standards over time. Our metadata currently is maintained in databases, but we also keep copies of the metadata in with the files. And then, of course, we maintain proxies on servers at this point, but copies of all of the proxies are also stored with the original content in the archive. This is also one of the implementations of AXF that we're looking at. We need some sort of wrapper, and right now we do it with tar. And if you've ever used tar, you know what kind of a challenge that can be if you ever change technologies behind the system. One of the things we're looking at is using AXF to be the wrapper for the archive file, the proxy file, the metadata files, the QC files, and have one instantiation, 2 different locations, but one file or archive object with everything with that UUID attached to it inside of that archive object. One thing I want to mention is the difference between an archive and a repository. An archive is where the contents are not meant to be accessed except when absolutely necessary. They must be preserved for long periods of time. They will require multiple migrations over time, and they can be part of a larger digital repository. In our case, 90% of our repository is an archive. They're actual archive content. A repository is where it contains all of the information and documents created by all business processes. That includes both archive files and day-to-day business files. An archive, of course, can be a subset, and non-archive data can be discarded after a certain period of time. Although one of the things that's been frustrating is in the federal space, we have a requirement to sunset all of our emails after 7 years. We erase all of our emails after 7 years. And we have had to fight tooth and nail with the folks who maintain our email system to keep the emails that were from 10 years ago that documented how we built our systems at NAVCC. Because they're like, well, the rule says we get rid of it at 7 years. Why would you need it after 7 years? Oh, I don't know, because I need to know how our SAMA encoders were developed. Oh, well, you don't need that. We're going to go ahead and erase that. What? The documentation on how we created our archive, you're going to erase that? And so part of our challenge has been business processes and business rule sets and institutional habits, shall we say. Our digital repository includes a 200 terabyte SAN, which is the staging area. It's the workspace for both transmission to the backup site and for staging into the tape library itself. The backup site has an identical SAN with an identical tape library, and then of course the tape library itself is the storage tech system. The data set, of course, is effectively permanent. The archive contents, however, must stand on their own, which means that no external databases should be required to know about the essence within a file. All of the self-descriptive metadata should be in the file. And that's part of where MXF AS07 is coming into play, because we realized that there were some ill-defined areas for fitting metadata into MXF as a standard that needed to be defined. And that's one of the areas that we're working with standards agencies on getting things to where they need to be. Any kind of storage system must be file format agnostic. It must be able to take anything that you throw at it. And then it must be scalable to a very large size. In other words, into the exabyte range with very low bit error rates. And in our case, our system manages 10 to the negative 19th. However, it must be migrated every few years. And one of the reasons that we've said, yes, we're going to go ahead and do migration is because it's less costly and complex than keeping the older capacities and the older technologies together with the newer ones in the archive. And it also takes advantages of the price reductions because every few years the storage capacity doubles for the same price and the same physical footprint. And right now, the math works for migration every 3 to 7 years. However, that could change. The current data tape that they use is barium ferrite, and roughly around 2025, our guidance is that the maximum capacity for barium ferrite will be reached. And if there is not a next technology that will keep capacities going after roughly 2025, then longevity will start being important. We won't be migrating every 3 to 7 years because it pays for us to do that. We will want to keep things for 10 or 20 or 30 years. And one of the amazing things that we've run into is some of our vendors have said, oh yeah, our data tape system, it lasts for 30 years. You know, you can buy this tape and it'll last for 30 years. And we're like, okay, great. Are you going to have data players to play that tape in 30 years? And literally without pausing, some of them have gone, well, why would you want that? What? You just said your tape can last for 30 years. How the hell are you going to be making machines in, T10KD in the year, 2047? Oh. And they literally had never thought about that. They'd never thought that they needed to make machines that would, if you're going to have a 30-year rated tape, to read that tape in 30 years. And so one of the things that we've done is for our earlier generations, the A, the B, and the C tapes, we've actually put a collection of both tapes and drives away with all the hardware and the software needed to read it. So in 30 years, we'll be able to tell whether or not these tapes can actually last for 30 years. That's one of the more interesting parts of our challenge. Being an engineer, I like to share this. I will not go through this in detail. However, what I will tell you is we've got two basic workflows here. This is our Born Digital workflow, how we bring things into the system. And you actually can't even read those things, can you? No. Well, if you want, I can send you a PDF of this. This is not a problem. And then this is our migration workflow, and this is our archive file storage. The glue for all of this is something called PCWA, the Packard Campus Workflow Application. It's a custom-coded set of software that ties all of our COTS products together because there was no overarching system that could handle everything that we needed, especially the interface to our 100 million item Oracle 11G database sitting in a piece of software called Mavis. And so we needed to tie everything together, and that's where PCWA came into this. And then for file movement, whether it be within the enterprise or it be from the enterprise to other folks, have been using Signient, and then we also use Aspera for bringing files into the library. And so some of the lessons learned over 8 years of production are that mass migration is not only possible, but it's actually relatively easy once you have the processes figured out. And I'll tell you that first 2.5 years, one of the reasons I'm at the library is I was actually one of the design engineers for the technical systems that went into the library. I worked for the systems integrator. And when you sit down at the table and you figure it out, that's the key part of it. You have to figure it out, and that's what takes the time. You can't short shrift the time. You also have to look at the physical workflows, the people, the cataloging, the movement of assets from point A to point B. All of it needs to be a dance that works together. They all must be created and implemented at the same time as the technical workflows, otherwise you will miss things. There will be things that present themselves and that I as an engineer didn't know, but the folks who are catalogers or who are the folks who take things and put them on the shelves or take them off the shelves that I didn't realize that had an effect on throughput, on getting things out of the vaults, on getting things back into the vaults, on getting the metadata done. There were things that needed to be taken into account, and you need to design everything at the same time. If it's possible to do it, you need to do it at the same time. And you need to make your system flexible enough so as you learn over time, you can make changes as necessary. And one of the key aspects of this is metadata is one of the most complex challenges, but it's also one of the challenges that must be solved. And as I'm sure any of you who deal with any kind of content, whether it be PSIP or it be metadata files or naming schemas and stuff like that, metadata is one of the most complex challenges, but it's also one of the ones that's going to make our jobs easiest and our successors' jobs easiest to find things, to find out what they mean, to find out what the rights on the content is, both copyright and licensing, yada, yada, yada. Metadata is one word that means about a dozen different things. And it can mean some very complex things, and we have learned that in spades. One of the other key things we've learned is get the humans out of the process as much as possible. We all have our stupid hour, where we've got the 1,000-yard stare. And one of the great parts about file-based workflows, about files, about IT systems, is for the most part, you can automate many of the processes. You can get the humans out as much as possible. However, you do need to accommodate where the humans come into it and where they should come into it. And so cataloging processes in our case had to be updated to raise the throughput, to enable large quantities of things to come into one spot, to have them cataloged all at once, and then move off to migration. And how it did it, when it did it, all of the things that go behind that. And one of the key aspects of this was the cataloging terminology. One of the things we learned the hard way is cataloging terminology, which is standardized in the library and archives community on a number of different standards, RDS, MARC, and a couple of other standards. Library of Congress authorities. We're actually one of the biggest standards organizations in the world, not because we have copyrighted versions of the SMPTE standards, but because we maintain the Library of Congress authorities list, which is the list of how do you name every single person, place, and thing in a cataloging record worldwide. The Library of Congress authorities is how libraries and archives and websites determine what Statue of Liberty really means, or John Smith, and how many different versions of John Smith are worldwide and what programs they were in. That's the Library of Congress authorities. The problem, of course, is that cataloging terminology and media terminology have two different terms for the very same thing. And how do we make those interoperate? And that's actually been a tremendous challenge. And then also born digital content production and reception. They're easy to create and receive, but not as easy to automate. And as with all of my presentations, I'm running late, so I will go through this quickly. Collections can be accepted as files from migration vendors and so on. Direct transmission is actually relatively easy. One of the key aspects that we've been working on solving, and we've done it on a limited basis, and we're looking on doing it at a large-scale basis, is how do we automate database record creation and file ingestion, again, to get the humans out of the system. And this is the part where I will skip through this. We do direct file transfers today. The US Senate, about 3,500 hours. Folks from Hollywood and the major networks. I wanted to make a plug for AXF, but since I'm running late, I won't. But we participate in AXF, and we're looking at various parts of our enterprise where we will implement, or we think we will implement, AXF. And then long-term storage planning, and a copy of this presentation will also be available after the fact. And then our data set migrations, we're trying for every 5 to 7 years. We thought we were going to be skipping a generation, but in fact, what we realized was the cost per unit was so low, we're now doing it every generation, at least for the next couple of generations. And one of the examples I was going to give is congressional video. One of our biggest challenges is how do we archive congressional video? We're the archive of the United States Congress, after all, and we actually fiber 58 720p 5994 channels down to Culpeper because it was actually less expensive to do that and produce the archive files in Culpeper than it was to put the equipment on the hill in the very tight spaces on the hill. And I'll let you read more about that. And then our Born Digital and other live capture copyright functions and so on. And I think this is actually a good place to stop. So thank you very much. And whoops. Thank you.